Greetings, students. Here to give you a little tutorial on how to navigate the confusion potentially of scientific notation and to convert between scientific notation and standard notation. You already should have watched the slideshow that gives you pointers on how to do it. So just very quick review, scientific notation is used for either very, very, very large numbers, like the distance between the Earth and the Sun, or very, 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 very small numbers. Like minuscule measurements would be an example where we use this practically. So basically what you're going to look for is, if you look behind me here, this little number here is an exponent of 4. It's not a negative, it's a positive, right? That indicates that you have a bigger number than 1. So 1.000, it's larger than that. If this were to be a negative 4, that would indicate a number smaller than 1. So 0.00 something, an example like that. So I'm going to use the blue marker. Hopefully it works. If not, I'll find a different color to work through a couple of problems for you. And if you're following along on Canvas, you'll see that there is an embedded Google form with questions. It would be a really good idea for you to follow along as I do this. It's going to help your life out a little bit. Let me just move this over a little bit this way so you can see me. All right, so the first question says, convert 3 point, I don't think this marker is going to work, 3.08 to standard notation. The number 3.08 times 10 to the second, sorry, I forgot to say that, is not in standard notation, it's in scientific notation. We have to convert this to like regular numbers. So I'm going to write the number down here, 3.08. I would encourage you to do the same thing. I'm trying to see if you can see that. I'm not sure if you can see it, but I wrote it down here, 3.08. And we need to go to the second power with it. This is a positive 2, which means this number that we get at the end is going to be a bigger number than 1. So if we're moving the decimal point to make it a bigger number than 1, we can't move it to the left because that's going to make it a smaller number than 1. We need to move it to the right, and how many spaces is going to be indicated by this number. So we move it 2 spaces towards the bigger number side, which is to the right. I've heard teachers talk about these little movements as booty cheeks or move it over humps. However you like to remember it, doesn't matter to me. So we're going to move it over 2 humps or 2 booty cheeks to the bigger side, which is the right. So 1, 2. And the decimal point would be right after the number 8 up here. So our final answer is going to be 308 with the decimal point at the end. You don't have to write the decimal point because it's implied. And that's your final answer, 308. Second question, I'm going to hand the marker over to Miss G so she can work that out for you.
Hi guys, I'm going to do number 2. Basically the same principle as number 1, just a different number. So convert 4.17 times 10 to the 4th to standard notation. Okay, I'm going to rewrite the problem. 4.17 times 10 to the 4th. Well, times 10 to the 4th, what that tells me is that I'm going to move 4 places to the right, okay, because it's positive. So you start where your decimal is, right here, and you move 4 places to the right. And I'm going to do that by indicating my little humps. 1, 2, 3, 4. And wherever you see the humps, you can insert a 0. So there's a 0, and there's a 0. 1, 2, 3, 4. So then you would take your decimal, and you would move it from the original place all the way to the end at the back of the last 0. So now your number, I'm just going to put an equal sign to indicate what the answer is 41700. Okay, and really, if you wanted to add your comma there, you would know that the actual number is 41,700. That's your answer. Okay, let's go to number 3. Convert 3.97 times 10 to the negative 3 to standard notation. So now we're dealing with negative exponents. Number 1 and 2 that Mr. Harrison and I did were positive exponents. Now we're working with a negative exponent. So that tells us what direction we should move. If it's a negative exponent, we need to move that many places, which in this case is 3. We need to move 3 places to the left from wherever the decimal is. So let's do that. Again, I'm going to write the problem down. 3.97. And this tells me that I need to move the decimal 3 places to the left. So here we go. 1, 2, 3. And when you move the decimal, you can do just like I did. Just make 3 little humps like that. Okay, so I did 1, 2, 3. And in those humps, you put placeholders, or which are your zeros. There's a 0, and there's a 0. So now that decimal is no longer after the 3. It is in front of the very first 0. I'm going to put an equal sign, so that way we know what our true answer is. The answer is 0, 0, 3, 9, 7. Okay, and of course, this number is much smaller than 1. Okay, let's move to number 4. How would you write 3140 in scientific notation? And when you think of scientific notation, all that means is when it has the power of 10 and then an exponent. So when I think of scientific notation, I think of it's the fancy way. That's written in a fancy way. And it wants us to write this number in the fancy way. Okay, so 3140 in scientific notation. How would we write that? Well, at the end of any number that doesn't have a decimal, the rule is the decimal is always behind the very last digit. Well, the last digit in this number is 0. So technically the decimal is behind the 0. Well, the rule is when you take a number and you want to move it to scientific notation, you take that decimal and you move it in between the first number and the second number. And the first number is 3 and the second number is 1. So I move the decimal between the 3 and the 1. Now you got to count up how many places you move that decimal. Well, if we start at the back of 0 and I move it in between the 3 and the 1, I count. 1, 2, 3. I moved it 3 places to the left. So I'm just going to rewrite this number with the decimal in it. I'm not done yet. All I did was move the decimal. Now I got to finish what it means to write the number in scientific notation. So it's 3.140 times 10. This is how you write in scientific notation. You write your number times the power of 10. And then how many places did you move? That's your exponent. So 3.140 times 10 to the third power. Now, should I make that exponent negative or positive? Well, since I actually moved to the left, I would make that exponent negative. Huh?
Positive.
Positive? Oh, see, okay. Well, I don't need to indicate. I was going to put a plus sign, but I'll just leave it positive. Sorry, my bad. So it's positive. So it's 3.140 times 10 to the third. Okay. All right, I'm going to give it over to Mr. Harrison.
So a couple of things on this one. If you have a decimal point with a 0 in it, remember the math rule is you don't have to include the 0 because it's at the end. Just like you wouldn't have to, like, if you had the number 2.10000, you don't have to include any of these zeros because they're at the end of the decimal. So it would also be correct to write this as 3.14 times 10 to the third Both answers would be correct. Neither of them are wrong. And I can see teachers get confused sometimes too, believe it or not, because we're not perfect and it happens to everybody. So one thing that I use for myself to keep track of moving left to right doesn't always help me as much. I look at this bottom line number here, and I'm going to erase this part of her work here for a second, just to show the original number. 3140. Keep it very simple. Is 3140 a bigger number than 1 or a smaller number than 1? If you're looking at this, it should be obvious that 3140 is a bigger number than 1. For example, 0.03 would be lower than 1. 3.14 is a bigger number than 1. Let me move this over just a little bit. Okay, so since this is a bigger number than 1, your exponent over here must be positive. Bigger. You don't have to write positive though if it's bigger, if it's positive. Last question. How would you write 0.000159 in scientific notation? So it's in standard this is in standard notation. We need to write it in scientific notation, and as Miss G just said, the scientific notation is going to have one number, then a decimal point, then the rest of the numbers. We're going to start here. I'm going to go crouch down a little bit here. Where is the first number that's not a 0 in this? We got 0, 0, 0. Oh, 1. So we're going to have to put it between the 1 and the 5. So I'm going to write 1.59 because that's the form for scientific notation. 1.59. Looks like a G. Okay, 1.59. That's the only reason I did that is because that is the form for scientific notation. One number, then a decimal, then the other numbers. And then I'm going to write the rest of how you write in scientific notation, which is times 10, and you're going to have some sort of exponent there, which we haven't figured out yet. So we got to get the decimal between the 1 and the 5 up here, and originally it's right here. So what we got to do is figure out how many humps it's going to take us to get between the 1 and the 5. So we're going to start here. We got 1 hump, 2, 3, 4. We moved it 1, 2, 3, 4 times to get it in its proper place right after the first non-zero number. Therefore, we're going to put an exponent of 4, but we are not done yet because we need to figure out if that exponent of 4 is going to be a positive or a negative number. Well, look at your original number now before I drew all over it. It was 0.000159. Is that number a bigger number than 1 or a smaller number than 1? Well, 0.000159 is a smaller number than 1, which indicates that we are going to have a negative exponent. So just to clear up any confusion, the really, really tiny numbers require like think of it in terms of like a microscope or something like that. If you're looking through a microscope to view something that's very, very, very small, then you're going to have to see something that's really, really small. Therefore, it's almost like, I don't know, negative just seems like small in my head. Whereas if you're trying to measure the distance between the Earth and the Sun, that's like a really, really, really big number. That means you're going to have like a positive exponent because it's way bigger than if we were to write it out. So that's one way that it helps me keep track in my head of how to do this. But basically what you do, just to run through the steps, is scientific notation has got one number, then it's got the decimal point, then it's got the rest of the numbers. So 1 decimal point, other numbers, and then it'll have times 10 with an exponent, either bigger if it's a really big number or smaller if it's a really small number like this one is. Do you have anything to say or are you done?
I am done.
Okay, well, thank you for watching. Hopefully this is helpful. Don't be afraid to ask questions. That's what we're here for. Thank you.